All right, so our first example of line integrals of vector fields, I think you'll realize that it's very similar to the line integrals we've been doing. You just got to know the formulas. So here's our vector field, and see, I'm actually just giving you the parameterization. So I'm not describing the curve to you. I'm just saying it's parameterized by this guy right here. And so let's go ahead and set this thing up so we can immediately write down the line integral along C of f dot dr, we know, is the integral from, in this case, 0 to 1 of f of r of t, and we're going to dot with r prime of t dt. And I want to work this out with you step by step. That's a dot there, not a, yeah, there we go. So integral 0 to 1. Okay, so I'm going to think about my f. Maybe we'll write f more in standard form. So this would be y plus z, comma, minus x squared, comma, minus 4y squared. So now I'm going to plug x is t, y is t squared, and z is t to the fourth into f. And so I get a, I get a t squared plus t to the fourth. I get a minus t squared, that's a minus x squared, and then a minus 4 y squared, t squared squared is t to the fourth. Then I'm going to take the dot product with r prime. Let's just compute r prime right here. So 1, 2t, and 4t cubed dt. And at this point, even though it doesn't feel like it, you're actually more or less back to a Calc 1 integral because the dot product is going to give you a scalar function. So integral 0 to 1, we're going to get, let's just take the dot product. So I get a t squared plus a t to the fourth. I get a minus 2t cubed, and then I get a minus 16t to the seventh dt. Nothing really can be combined there. All the powers are different. So I'm not going to work this out just for time's sake, but I'll tell you that when you do, you get a negative 59 over 30. And so, again, there is a way to physically interpret this number. It's telling you that the work done moving by this vector field, moving a particle along this curve is negative. So you know that overall the vector field is actually pushing against the particle more than it's pushing it forward. So let's stop this video here, and we'll do another example in the next one.